Hello, welcome to the presentation of my Capstone 2 Supervised Learning project. My name is Kevin Mo. Today, I'm going to talk about telecom company customer churn prediction. First, let's have a brief introduction of customer churn prediction and the motivation of this topic. So first, what is customer churn? By definition, customer churn means the behavior that customers stop using certain company's service or product during a predefined time frame. For instance, if you were using AT&T phone service and later switched to Verizon, this would be considered as customer churn. Note that customer churn is not limited to a telecom company, but also any companies that have subscription services. But today, we just focus on telecom companies. So the second question is, why is customer churn analysis so important? The answer is because a large proportion of revenue of a telecom company comes from customers, if not all of them. So losing customers means losing money. Also, it is normally more costly to acquire new customers than to keep the existing customers. And that's why telecom companies care about customer churn. So the question for data scientists is, how can we help? Note that the ultimate goal for a company is to prevent customer from quitting. But first of all is to find out their target customers. And this is customer churn prediction. It simply means by using historical data, we'd like to find out whether certain individual customers will stop using their service or product. In the language of data science, we call it a classification problem because we will classify the customer into two groups, churn or not churn. And normally, we will use supervised machine learning method to tackle this problem. Here is a pipeline we can use for customer churn prediction. I borrowed this figure from Thankful website, and I'm assuming you are very familiar with the process already. And here, what I would like to emphasize is that this process is an iterative process, which means, for instance, after you finish data cleaning, you may have to come back again if you realize the data is not clean enough after data exploration or feature engineering. And this is what I have experienced in this project. Many times I have to come back again and perform either data cleaning or data exploration or feature engineering. And in this presentation, I will go through the supervised learning pipeline I just mentioned earlier. For data preparation part, I will cover data cleaning, and it includes missing data fixing, data type checking and reformatting, trash data disposal, and later I will talk about data exploration. I will cover data distribution visualization, outlier checking, normality establishment, how to check collinearity and check imbalance. And later I will talk about how I split the training set and the test set in this project. And I will also cover feature engineering, how I perform quantile transformation, how I handle categorical variables using one-hot encoding, and select k-best and the PCA. And for the modeling part, I will start with how I how I generated a baseline model for prediction. I call it a dumb model. and I will talk about the evaluation and how I implemented 7 different types of machine learning models in this project, which includes logistic regression, support vector machine, KNN, naive Bayes, decision tree, random forest classifier, gradient boosting model. And last but not least, I will talk about grid search CV for hyperparameter tuning. And after that is just a summary. Okay, now let's dive into Jupyter Notebook.